Hey, Wagwan. Yeah, man, I'm Mr. Garthreed here. We're going to be looking at a Cape Applied Mathematics Unit 2 question from the May-June 2011 past paper. All right? I believe that this question is from the paper 3. And the question says that we are to use De Morgan's laws to prove that the negation of P and Q or the negation of P is logically equivalent to the negation of Q and P. All right. So yes, we are indeed supposed to use the De Morgan's laws. All right. And I have it here. I have it right here. Okay. But although we need to use De Morgan's laws, there are other laws as well that we need to use in order to prove this statement. All right. Now, if you would like a document, a PDF document of all of these laws, including the others, all right, you can access that on my website. The link will be in the description of this video. Okay, let's get into the proof. We were asked to prove the negation of P and Q, or the negation of P is equivalent to not Q and P, right? That's what we're trying to prove. All right, let me just scroll down a bit. Okay, so we need to use De Morgan's laws first, all right? Now let's look at the De Morgan's laws here. I have not the negation of P and Q, right? So when I expand the brackets and I put the negation inside, it becomes the negation of P right here, right? But notice that the connective changes, all right? So if it is and, it changes to or, and then we get not Q, all right? Similarly, if we had the negation of P or Q and we expand, right, we get not P, but the connective changes to and, right? And then not Q. Good. So that is the law that we'll be using first, De Morgan's laws. Okay? So if I use De Morgan's laws, what I will get is the negation of P and Q. All right, but notice that the connective here will change. So it will change to and. All right, and I have the negation of P. Ensure to use brackets, okay? Good. So each step that you are going to do, you should ensure that you write what law you used, okay? So here we used De Morgan's law. All right, we use De Morgan's law there. Good. So in order to get maximum marks in the examination, all right, you are required to ensure that you put what law you used in each step. Okay, so this is now logically equivalent to the negation of P and Q, and now I'm going to be using the double negation law. If I have the negation of P, that is equivalent to P. Okay, that is equivalent to P. So it means that I can write P here, right? Because the negation of P is equivalent to P. Good. That is what we have. So I'll just use the double negation law. So let's write that. So double negation law. All right. That is what we have. Good. What am I going to do next? I'm now going to use De Morgan's law once more, okay? Because I'm now going to expand the brackets for the P and Q, okay? So when I do that, I'll be basically using this rule here, okay? that rule there. So if I have the negation of P and Q, that is logically equivalent to the negation of P, the connective changes to or, not Q. All right? So that is what I'm going to write here. Let's do that. So this is now logically equivalent to the negation of P, the connective changes to or, the negation of Q. All right? Good. And remember that we have the and P on the outside. Okay, so this is still in brackets and P. Okay, it is still in brackets because you recognize that the connectives are different. You have not here, you have or here, sorry, and you have and here. So you cannot just leave it open like that. You have to include the brackets. Okay, so we just use De Morgan's law. Let's write that. De Morgan's law. Okay, good. That is what we have. Okay, now what am I going to do now? I'm now going to use the negation law. Okay, sorry, I'm going to be using the distributive law and then the negation law after. All right, let's look at the distributive law. So the distributive law says if I have P and Q or R, that is logically equivalent to P and Q or Q and R, right? Like it's like, for example, you're using two different operations in regular arithmetic, right? That's kind of a simpler way to put it. Because let's say one sign is plus and one sign is multiplication, right? One side is multiplication, one side is plus. That's basically the distributive law. All right? Okay, so let us now use the distributive law here. So I can now say that this is logically equivalent to P and not Q, not P, sorry, P and not P, all right? So P and not P, okay, that is going to be in one brackets, or, all right, this or here will come here, P and not Q, all right? P and not Q. So the operation that will come in the bracket, is from here, okay? But the one outside, the connective that is outside is from here, okay? So I hope you see that. So we have just used the distributive law. So let us now write that. So we have just used the distributive law. Distributive law. Okay, good. So this is now logically equivalent to, okay, now we're going to be using the negation law because here you recognize I have P and not P, all right, P and not P. So let us look at the negation law. It says that P and not P is logically equivalent to F, right? F just means false. So that is always going to be a false statement. That is what it is saying. All right, let's write that. So I can write false here, false, or, and I'm now going to write back the P and not Q. All right, good. So I've just used the negation law. So let us write that. So negation law. Okay, good. So we are one step closer to where we want. All right, now I'm here, but how will I end up with not Q and P as my answer? All right, I will now be using the identity law. Okay, let us look at the identity law. The identity law is over here. All right, it says P, there are two of them, but remember our connective here is or. All right, so it says P or F is equivalent to P. All right, so P or F is equivalent to P. It is the same thing as saying F or P is equivalent to P because of the commutative law, right? It doesn't matter what order the P and the F is in, all right? This will always be equivalent to P. But what if I don't have P, all right? What if I don't have P? Because let's look at it. Here I have F or P and not Q, all right? I don't have P, I have P and not Q, okay? So what I'm going to do is to use this as my P, all right? Use all of that in the brackets as my P, okay? So I know that if I have F or P, that is logically equivalent to P, right? But what I'm saying here is that I don't have P. I have P and not Q. So this is now going to be logically equivalent to P and the negation of Q, right? It is in the place of P, okay? And F or P we know is P, okay? So I hope that was clear enough. So just now write that. All right, let's write that here. So F or P and not Q is going to be logically equivalent to P and not Q. Okay, good. And I have just used the identity law, so just write that. So I just use the identity law. Good. That is what we have. Okay. All right. So we're one step closer. Let us look at what we have and let's look at what they want us to show or to prove rather. So P and not Q here. All right. That's what we have. And in the question, it says that we're to show that it is logically equivalent to not Q and P. All right. But if I have P and not Q, isn't that the same as not Q and P? Yes, it is, because of the commutative law. All right. This is the commutative law here. Okay. So if I have P and Q, that is logically equivalent to Q and P. And if I have P or Q, that is logically equivalent to Q or P. So if I have not Q and P, it is also logically equivalent to P and not Q. All right. So it doesn't matter what order the propositions are in. All right. So what I'm saying here now is that this is now logically equivalent to, all right. So remember on the left hand side, I had the negation of P and Q or the negation of P. All right. So if I have P and not Q, it is logically equivalent to not Q and P. Okay. And that is because of the commutative law. So the commutative law. Okay. And that is our proof. All right. So I've finished the proof for this question. All right, use De Morgan's laws to prove that the negation of P and Q or the negation of P is logically equivalent to not Q and P. Okay, I hope this video was helpful. If it was, please ensure to like up this video and comment down below. All right, and remember, if you would like a PDF document of all of these laws that you are to know, all right, you can access it on my website and the link will be in the description of this video. Okay, I am Mr. Garth Reed, student ambassador in the University of Technology, Jamaica, and I'm a mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.